Boys and girls, this is Mr. Manise again here with another cool video, and in this video I'm going to walk you guys through step by step for how you solve each of the problems on the quadratic graphs quiz review. So as customary, I always like to throw in a nice funny little GIF right here. So if you didn't know, this is a Clemson football player named Hunter Renfrow who just so happened to catch the national championship game-winning reception against the University of Alabama. So there you go. Hunter Renfrow will go down in history, one of the best catches in Clemson football history. All right, so let's go ahead and jump in to the quiz review. Let me zoom in here just a little bit. So if you guys would like to get out your graphing calculators, you're going to need those as we work through some of these problems. These first couple of problems, we're just looking at the different attributes and characteristics of my graph. Let me zoom in one more time. Okay, so the first one here is asking for the vertex, and the vertex is simply the top or bottom of my roller coaster. So my quadratic graph, my roller coaster is going up, it's hitting a high spot right here. So we're just trying to figure out what are the coordinates of that spot. And we're going to go left -3 and we're going to go up 2. So the vertex is going to be -3, 2. And if you see the word extrema later on the quiz review or on the quiz, extrema is just another word for vertex, so they mean the exact same thing. Okay, the next one's asking for the roots or the x-intercepts. Now remember, roots, x-intercepts, zeros, solutions, answers, all of those words are synonymous. They all mean the exact same thing. So when they ask for roots, that's x-intercepts, is where's the graph touching or crossing the x-axis. So I'm touching or crossing the x-axis in two different spots here. Thankfully, in this case, they are nice, pretty, round whole numbers. Okay, so there are the two different ways you can write the roots. I teach most of my students to think about them as x-intercepts, their coordinate points. So the coordinate point of that guy is simply -4, 0, and the coordinates of that guy are -2, 0. Okay, so technically those are the x-intercepts. If you want to write them as roots, technically you can just write -4 and -2, basically just the x-coordinate of the x-intercept, and those would be acceptable answers for the zeros or the roots. So either one of these is perfectly fine. Domain, they're all my x values. So you got to get out your broom. You got to sweep from left to right like you're reading a book. Where do I have x values? Well, this graph goes on forever and ever and ever, all the way down to -infinity, all the way down to -infinity. So as I sweep from left to right, I have x values everywhere. Out here at -7, you don't see any part of the graph, but if I extend this down, this -7, it will eventually hit the graph. And this goes on forever and ever and ever. So way out here at -infinity, I will have x values. They're way down off the page, but I have them. Out here at positive infinity, I do have x values. Way out here at 100, at 10,000, at infinity, I will eventually touch my graph down here. I do have x values everywhere. So for every single quadratic on planet Earth, whether it's a right side up or an upside down U parabola, your domain is always -infinity to infinity. Okay, range. We kind of have fun in my class. I ask my students if they've ever seen the movie Karate Kid. Sweep the leg, paint the fence, wax on, wax off. So don't ask me why, but that's just what I think about when I think of range. I think of paint the fence, where he's literally taking his hand, he's painting up and he's painting down, he's painting up and he's painting down. So we're painting up the fence, okay? We're sweeping. Normally we're only looking at the x values, okay, when we talk about graphs, but this is one of the few times where I'm getting out my broom and I'm sweeping from bottom to top, okay? So down here at -infinity on the y values, on the y-axis, and I'm not even looking at these x values. Don't even look at them. Ignore them. Don't pay attention. I'm only looking at these y values on the y-axis. So down here at -infinity, as I'm sweeping from bottom to top, do I have any y values? Well, right here at this point in the graph, yes, I've got a y value. That y value is -6. Down here, that y value is -7. Down here, and this thing goes on forever and ever and ever. So down here at -infinity, way down at the bottom, I do have y values. I have y values everywhere. And I will have y values as I sweep up. I will continue to have y values all the way until I get to the top of my roller coaster. Right there, above that spot, I don't have any y values. There's nothing up here. If you look at a y value of 3, there's nothing up here. This is all just void empty space up here. Okay, so my range as I sweep from bottom to top will be -infinity. Okay, -infinity all the way up till I hit a y value right there of a +2. Okay, now technically we'll put parentheses on the infinities, and technically when we have these values, technically we're supposed to put a bracket right there because my graph actually does include, it does touch 2. So that's just kind of a technicality there with the bracket. All right, so for the right end behavior, okay, the end behaviors are really simple. It's just how is the graph behaving at the end, okay? Well, all you got to do is look and see where are these arrows pointing. Where is the graph headed? Okay, both of these arrows are pointing down. Okay, so as x goes this way, as x approaches negative infinity, sometimes I like to use my fingers. As x is going this way with my finger, where's my graph going? My graph is going down. As I go this way, the graph is going further and further down. All right, so as x approaches negative infinity, y is going down. Now in this case, they only ask for the right end behavior, but normally they ask for both of them together. So in this case, technically they're only asking as my x goes this way, as we're approaching positive infinity, where are my y's headed? They're both headed towards negative infinity. Okay, so really the right end behavior would be as x approaches positive infinity to the right, where is the y going? The y is approaching negative infinity. But basically the end behaviors, all you have to remember is both of the y's are they're both headed down, if it's upside down, or like in this case, both of the y's are headed up. Okay, so the y's are either both going to be positive infinity or the y's are both going to be negative infinity. Okay, so number 2, they're asking for the axis of symmetry. Okay, so remember the axis of symmetry is an imaginary line that you can't see. It's always going to be a vertical line because it passes through the vertex. Okay, so we got this imaginary line that cuts through the vertex. And it's always going to be x equals. Okay, x equals something because it's a vertical line. How do I know whether it's x equals or y equals? The way I remember is whatever axis the horizontal or vertical line crosses, that's what the equation starts with. So this imaginary vertical line that passes through the vertex is cutting through the x-axis. So my equation is going to start with x equals. So for every parabola, every quadratic on planet Earth, it's always going to start with x equals. Okay, and then it's just a matter of figuring out where does it cross the x-axis. Here it crosses at -2. And I also teach my students that basically the equation of the axis of symmetry is going to be the x-coordinate of the vertex. Now this particular sheet doesn't ask for the vertex. Let's just go ahead and write it in. It's just good practice. The vertex on this one would be -2, 2. Okay, so notice that the axis of symmetry is the same as the x-coordinate of the vertex because it passes through the vertex. Okay. All right, y-intercepts, where does the graph cross the y-axis? That's going to be this spot up here. Okay, so it's crossing at 0, 6. Okay. Again, they don't ask for this. Let's just go ahead and write it in. This is just good practice. If they were to ask for the range on this one, the range over here was upside down, so it was from negative infinity up to the top of the graph. Well, over here, I don't have anything down here at negative infinity. I don't have any y values. This is all empty void space. So as I sweep, as I paint the fence, Karate Kids, I paint the fence. Starting down here, I got nothing. And I have nothing. I continue to have nothing until I hit a value of 2. So in this case, my range would be 2 with the bracket. And then where do my y values stop? They don't stop. They go on forever and ever and ever all the way up here to positive infinity. Okay, so my range would be 2 to infinity if you see that on the quiz. All right. Left end behavior is the same thing as the other ones, except we're going to the left. So as x approaches negative infinity, as we go to the left, where's this graph going? It's heading up. Okay. So as x goes to the left, as it approaches negative infinity, the y's are both headed up. Okay. So in this case, the left end and the right end behavior, both y's will be headed towards positive infinity. Okay, so let's move on down to number 3. Okay, so it says graph each quadratic, make a t-chart. Okay, so I need to be able to graph my 5 points. Okay, we really need 5 points to plot an accurate graph for quadratics. Well, how do I get those 5 points? We're going to use our calculator, our trusty old calculator. But in order to use my calculator and to get some points out of the table, I need to figure out what the vertex is. Everything around the quadratics is kind of centered around the vertex. So how do I get the vertex? Well, if you notice, this is in vertex form. Vertex form is y equals a times x minus h squared plus k. So when you see the parentheses squared piece in the equation, that's a red flag. Hey, I'm in vertex form. Okay, so vertex form. When I'm in vertex form, the whole reason of being in vertex form is so I can immediately tell you what the vertex is. All you got to do is flip the sign of the guy in the parentheses because we're subtracting the h. Your vertex is h comma k. So I flip the sign of the guy in the parentheses, so that's going to be minus 1. And then here's the k. I leave that sign alone. Flip, leave alone. So my vertex is -1, 4. Okay. Now I like to come down here to my t-chart and go down about halfway. Go ahead and write your vertex. I like to put a box around it. I like to write a little V so my brain says, okay, here's the vertex. And now I need 2 points above it and 2 points below it. So here's where we're going to use our calculator. Let's zoom out here a little bit. Zoom out one more time. There we go. Okay, so turn on your calculator. You're going to go to y equals, this button up here in the top left, press y equals. If there's anything in there, press the clear button, clear that out. Let's go ahead and enter in our equation exactly the way you see it. Y equals -2. Now remember, some of you guys are making a mistake. You've got to press this negative button. Don't press the subtraction button when it's really a negative value, okay? So press -2, parentheses, x plus 1, parentheses, press this little squared button right here, press the x squared button, and then plus 4, okay? Or you can press the graph button. Let's just see what it looks like. Okay, if your screen doesn't look like this, guys, if you see some wacky screen, press zoom and then select 6. Option 6 gets you back to your standard window. I'm already in the standard window, so I'm good to go. Okay, so that's what my graph looks like. Okay, fine. I need to get my 5 points. I already have the vertex, so I need to go to my table. Okay, so you're going to press second and press the table button up here at the top right. Second graph or second table. There's my table of values. Okay, sometimes I've seen some of you guys have calculators where your table values are all messed up. It's jumping in increments of 10 and starting at -300. If your table doesn't start at like 0 and 1, see this blue table set button? Press second table set, and you need to make sure that your table is starting at a value of 1. Okay, so let's change that to a 1. And then this delta table, this is telling you, hey, I want my table to jump up in increments of 1. Sometimes I've seen you guys have increments of 30. So when you go to your table, your graph is literally jumping up in increments of 30. We don't want that. Go to second table set. Table should start at 1, and the increment should be 1. Okay, that's just in case you guys see that problem. Okay, so let's go back to second table. I need to scroll until I see the vertex -1, 4. So let's go up. Go ahead a few clicks above it. So let's scroll down. There's our vertex, -1, 4. Now I need 2 points above it and 2 points below it. So I'm going to grab this -2, 2 above it. Then I'm going to grab the one above that, -3, -4. And then I'm going to grab the 2 points below it, 0, 2, and 1, -4. 0, 2, and 1, -4. And that's how you get your 5 points using the table feature on your graph. All right, so now it's just a matter of plotting these points, -1, 4, -2, 2, -3, -3. Oh, that's sorry. That should be a -4. Yeah, sorry. -3, -4, 0, 2, and 1, -4. Okay, there are my 5 points. And let's go ahead and connect the dots. All right, there you go. That's how you graph it when it's in vertex form. Okay, number 4, they weren't so nice to us. Okay, let me zoom back in on this one. They weren't so nice to us. I'm not in vertex form. I'm in standard form. How do I know that? I don't see any parentheses. Okay, there's my A term, my B term, and my C term. I'm in standard form, so I don't know what the vertex is right off the top of my head. When I'm in standard form, I just flip the sign and I can go immediately to my vertex. So here, you're going to either need to do one of two things. I've taught most of my students how to use Mr. Spidey in their calculator. If any of you guys are watching this video that never had me, you got another geometry teacher, they may have taught you the little trick where you use -b over 2a. So my b would be -4, so it would be 4 over 2 times 2. You would get that value, that would be the x-coordinate of your vertex. You would get whatever value you got, take that x, plug it back in for x here, and calculate what your y is. That's how you solve for the vertex manually, okay? 99% of my students have a calculator, and they use Mr. Spidey, okay? So we're going to use Mr. Spidey, so let's go ahead and get out our calculator here. Scooch this over a little bit so you can see. Alright, so let's go y equals and let's type in our equation. Let's clear that. Let's go 2x squared minus 4x plus 1. And I want to graph it. I just want to see what it looks like. Okay, good. I can see the vertex. Okay, if you're using this little trick with Mr. Spidey and you can't see the vertex, if the vertex is off the screen, this is where you got to use that trick I showed you in class. Zoom and go down to Zoom Fit, which is basically 0 or number 10. I don't need to do that because I can see my vertex, but that's just an option for you if the vertex is off the screen. But I can see the vertex. Okay, so now I need Mr. Spidey. How do I get Mr. Spidey? Calculate. Okay, I want second calc. Okay, now I've got to figure out, I want the vertex, so that's either a minimum or a maximum. Okay, what do we have? Well, that's a minimum. That's the low spot of my roller coaster, so I need minimum. Second calc, I'm going to select minimum, press enter, and now I have Mr. Spidey. Okay, if you can't see Mr. Spidey, if he's off the screen somewhere, like this, if he's off the screen, just look at the coordinates. He's at -2, 18, so he's up here somewhere, so that means I need to move Mr. Spidey. Here he comes down the spider web. Okay, so your calculator needs a left bound, so I just need to move Mr. Spidey anywhere to the left of the vertex. That's good. Press enter. Now your calculator is asking for a right bound. Okay, let's move Mr. Spidey to the right. Here we go. That's good. Press enter. Do you want me to guess, Mr. Manice? Yes, I want you to guess. Go ahead and press enter for a third time. And there you go. There is your vertex. Do not ask me why your calculator does this wacky 0.999. I think it's just a glitch in the Texas Instruments software. Your vertex is 1, -1. Okay, so just round that. All right, so my vertex is sitting at 1, 1. So if I come out here, vertex is 1, -1. All right, so now let's come out here to our T-chart. Let's go about halfway down, 1, -1. Let's put a box around that, a V, so that's the vertex. So now I'm going to go back to my table, press second, table, and now I need to scroll to my vertex, which is 1, -1. Go a couple clicks below that, and now let's get our 5 points. We've got 0, 1, -1, 7, whoops, second table, and we've got 2, 1, and 2, 3, 7. Okay, so there are my 4 points. So let's graph. We've got 1, -1. There's my vertex. We've got 2, 1. 3, 7 is actually off the chart a little bit, but that's okay. It's up here somewhere. 0, 1, and -1, 7 is also off the graph. That's no problem. And let's connect the dots. And we have graphed it. Okay, very good. Let's move on over to the back. All right, so we got some more graphing. All right, so where are we? Is this standard form or is this vertex form, number 5? That is standard form. I don't see any parentheses, so we're going to have to do it the long way. That's no problem. Y equals, let's go negative, don't forget that negative x squared plus 4x. Now remember guys, you can complete the square on this. You can complete the square to go from standard to vertex form if you want to. To me, it's just a lot easier to type it in a calculator, use Mr. Spidey, go to the left, press enter, go to the right, press enter a third time, and get the vertex that way. But absolutely, you can complete the square to get that vertex that you need. -3. Okay, let's graph it, see what it looks like. Okay, so I can't see it here. Okay, so I can't see my vertex. So this will be an example where I might want to use the zoom fit button. So let's press, make sure I've typed that in right. Yeah, okay, so press zoom and go down to 0 or number 10. Zoom fit, press enter, and then my calculator zooms right in on the vertex there. Okay, if that doesn't work, if you still can't see the vertex after the zoom fit, then just zoom out again. Press zoom, select number 3, and then press enter, and then we can zoom out again. Okay, so the zoom feature is wonderful to find the point that you're trying to find. In this case, we're trying to find the vertex. All right, so now I can go second calc. All right, is that a min or a max? Okay, that's a maximum. Roller coaster goes up to a top. That's a maximum. So press second calc, and now I'm going to select maximum. And now there's Mr. Spidey. So I just need to move Mr. Spidey to the left of the vertex. That's good. Press enter. Move Mr. Spidey to the right. That's good. Press enter a third time, and there is my vertex. Okay, -6, 36. Let me check something real quick. X squared plus You know what, guys? I think I typed that in wrong. I'm so sorry. Let's go back to our standard window. I'm so sorry, guys. I'm so sorry. I typed this in wrong. I realized I did something. I think what it was, I think maybe that was a negative instead of a subtraction sign. So, see, even I make a mistake. All right, so let's go back. If you type this in correctly, negative x squared plus 4x minus 3. If I graph that, we don't need to zoom in on anything. So go ahead and press zoom 6, get back to your standard window. So I knew something was wrong. I knew that vertex wasn't right. Okay, so, so here my vertex is a little bit easier to see. Okay, so that's a max. So we'll do it again. Second count, select maximum. All right, so there's Mr. Spidey. Just move Mr. Spidey to the left. That's good. Press enter. Move Mr. Spidey to the right. That's good. Press enter. Yes, press enter a third time. And there's my vertex, 2, 1. Okay, so vertex is 2, 1. All right, let's get our T-chart. Okay, so let's go second table. And let's scroll down to 2, 1. There it is. Let's grab some points above and below. So we've got 2, 1 vertex. Let's grab 2 points above it, 1, 0, and 0, -3. 2 points below, we got 3, 0, and 4, -3. Okay, so there are my 5 points. Now I can plot 2, 1. There's a vertex, 3, 0, 1, 0, 4, -3, and 0, -3. Okay, let's go ahead and graph that. And now we can start answering some questions about the characteristics and the attributes. Vertex, we already know what that is, 2, 1. Roots, okay, now remember that's x-intercepts, zeros, x-intercepts, roots, they all mean the same thing. That's crossing at a nice pretty whole number right there, 1, 0, and 3, 0. Those are the spots where my graph is touching and crossing the x-axis. If you wanted to write it as a root, you could write 1 and 3, that would be fine as well. Y-intercept is a nice pretty number. Your y-intercept is where your x is 0 in the table. So I just looked to see, yes, I've got a 0 in the table under x, so that's my y-intercept. That guy is the y-intercept, 0, -3. And then the range, Karate Kid, paint the fence, sweep from bottom to top. We do have y values down here at negative infinity, okay, because my arrows are pointing down. So I have y values from negative infinity as I sweep up, and I will continue to have y values all the way until I hit a y value of this guy right here. Okay, so that guy is a 1. I don't have any y values above this horizontal line. So my range is negative infinity up to 1. Technically, I need to have a bracket on the 1. Okay. All right, one more graphing. Is this standard form or vertex form? Well, I don't see any parentheses, so I'm in standard form. Okay, so we're going to have to use Mr. Spidey again. So let's go y equals, let's type in our equation, 3x squared minus 5. I don't see 3 terms. I don't have a b term, but that's okay. I'm still in standard form. It's just that my b is 0. Okay, so let's graph that, see what that quadratic looks like. Okay, good. I can see everything on the graph. Press zoom standard if your graph doesn't look like that. All right, so that's a minimum. Okay, so now I go second calc. I want Mr. Spidey. So I'm going to select the minimum. There's Mr. Spidey. I just need to move him anywhere to the left. That's good. Press enter. Move him anywhere to the right. That's good. Press enter. Press enter a third time. And there is my vertex. Now, what in the world is this mess? Holy cow. 2.6 e to the -6, guys. That's scientific notation. That means it's got 6 zeros behind it. Okay, so that's 0.000000260. I don't know why Texas Instrument does that. They need to fix this. That's basically 0, guys. Okay, so obviously your minimum is sitting right here at a x value of 0. So my vertex is 0, -5. So don't let that trip you up. Okay, 0, -5 is the vertex. Okay, so let's go down about halfway. 0, -5. Okay, that's a vertex. Put a V for vertex. All right, let's go second table. Let's grab some points. 0, -5. Let's get 2 above it. So 1, -2, -1, -2, and -2, 7, and 2 points below it. 1, -2, and 2, 7. Okay, so there are 5 points. Let's plot these. 0, -5. That's my vertex down there at the bottom. 1 comma negative 2, 2 comma 7. I'm off the chart again. That's okay. Negative 1, negative 2, and negative 2, 7. And they weren't very nice to us, were they? Look at all these points going off the graph. That is okay, though. Alright, so there is my quadratic. Axis of symmetry is this imaginary line that goes right down through the middle. So remember, axis of symmetry is always x equals, and it's always the x coordinate of the vertex. So in this case, it's x equals 0. It's basically the y-axis. The y-axis is the imaginary line that splits that quadratic in half. Extrema is just another word for vertex. V for vertex. That's 0, negative 5. Domain is always, don't even look, don't even think about it. Domain is always negative infinity to infinity. And the end behaviors, now this time they don't say left or right, okay, so we're going to use both. As x approaches negative infinity and then as x approaches positive infinity, okay. Well, where are both arrows pointing? They're both pointing up. So in both of my end behaviors, both of my y's are both headed towards positive infinity, okay. That's what you need to remember. Both y's are either headed both up or they're both headed down. Okay, let's finish up here with completing the square to get a vertex form. Okay, so we're going to have to do this manually. Alright, so remember to complete the square, I like to put these little brackets so my brain says, okay, I'm only completing the square on those two terms. Okay, let me zoom in here a little bit. Okay, so how do I complete the square? So I've got y equals my first two terms, x squared plus 8x. Now here's where I'm going to complete the square. So I got my plus blank. Alright, and then that's a little fuzzy. Zoom back out a bit. I may be zoomed in too close for it to not be fuzzy. Okay, so then I've got my minus 5, and then I've got another blank. Okay, so I'm going to complete the square on the b term. How do I complete the square? It's always half of b squared. Take the b term, divide by 2. In this case, my b is an 8, so I'm going to divide that by 2. That's 4. And then I'm going to square it. So 4 squared is 16. Okay, so this is the magic number that I'm going to stick into this blank. I'm pulling a 16 out of thin air, and I'm just throwing it into the equation. I can't do that because now I've changed the equation, so I have to come over here. I have to offset that with a negative 16 so that the 16 and the negative 16 cancel, and I'm right back where I started. Mr. Manice, why in the world did you do that? Why'd you pull a number out of thin air? Well, the reason I did that is so now I can factor this special case perfect square trinomial. Go ahead and bring down the y equals. I want to put it in vertex form. I want to go to this form. So when I get done, I want to be in this form with a parentheses squared piece. Now what goes in the parentheses squared piece? It's simply going to be half of this number, half of the 8. Okay, if you take b divided by 2, if you take half of 8, you get 4. So that's what goes in the parentheses squared. It's going to be an x plus 4 because half of 8 is 4. Over here, I just simply combine my like terms. Minus negative 5 minus 16 is a minus 21. Okay, so now I'm in vertex form. My vertex is going to be flippy flip, leave alone. Flip the 4, negative 4, and then leave the negative 21 alone. Okay, so the vertex is negative 4, negative 21. Okay, number 8. Let's put our brackets here. So I've got y equals x squared minus 6x. Let's make room. Let's give us a plus blank. That's the room for the magic number. Minus 5 and then another blank. Okay, so complete the square. Half of b squared. Take half of b. Negative 6 divided by 2 is negative 3. I'm going to square negative 3 and I'm going to get a 9. Okay, so I'm going to stick a 9 in that blank. I'm going to offset that with a negative 9. Okay, now why did I do that? So that I can factor this perfect square trinomial. I know it's going to be y equals parentheses squared. Just write it down. To figure out what goes in there, you take half of that number, half of b. Half of negative 6 is negative 3, so it's just an x minus 3 every single time. Combine your like terms, combine the negative 5 and the negative 9, you get minus 14. So my vertex in this case would be 3 comma negative 14. Alright, one more, we can do it. Hang with me. Feel free to stop and pause the video. I forgot to say my disclaimer at the beginning of this video. Do not come to this video and just watch me work these problems and just copy it down on the quiz review and turn it in. That's not going to do you any good. You need to work these problems on your own. Then come to the video and see where you might have made your mistake or have a misunderstanding. Okay, let's put our brackets here. Okay, so we got y equals x squared plus 10x. Let's make room for our magical number, blank plus blank. Minus 12 and then another blank. Okay, half of b squared, half of b squared, half of b squared. Can't say that enough. Take half of the middle term, take half of 10, which is 5. Let's square that, and it gives me 25. So I will stick a 25 in that blank. I will offset that with a negative 25 in the other blank. Okay, that allows me to factor this perfect square trinomial. So go ahead and write down your y equals parentheses squared piece. How does this factor? Take half of the b term. Half of 10 is 5, so I'll put an x plus 5. Okay, x plus 5 squared. Now let me just stop here for a second, real quick. I always have students ask me, well, what happened to the 10? Well, I don't understand. What happened to the 25? How did you go from here to here? I don't understand how you did that. Well, the 25 didn't disappear anywhere. Okay, if I ask you what are the factors of 6, well, most of you guys would tell me 3 and 2. The factors of 6 are 3 and 2. 3 times 2 equals 6. So when I say 3 times 2, where did the 6 go? It didn't go anywhere. 2 times 3 is equal to 6. The factors of 6 are 3 and 2. So the 10 and the 25 didn't go anywhere. The two factors that I can multiply that will give me x squared plus 10x plus 25 are x plus 5 times another x plus 5. Or in other words, what you can think about it factoring a trinomial where a equals 1. What are the factors of 25 that add to 10? 5 and 5. So we would say, okay, that factors is x plus 5 times x plus 5. Well, I can just rewrite that as x plus 5 squared. So I want to make sure we're clear on that. These numbers didn't disappear. This is just how it factors. Okay, so negative 12 minus 25, I'm going to, whoops, blue gives me minus 37. Okay, so the vertex would be flip, leave alone. Vertex would be negative 5, negative 37. Okay. All right, so hope you guys enjoyed. Oh, one last thing, almost forgot. You can use the calculator trick that I taught you guys at the beginning of the year to check these. Please take 25 seconds, 15 seconds to check these, I beg you. Let's type in the original equation, x squared plus 10x minus 12. Press enter, okay? Do I care what that number is? No, I don't care what that number is, okay? I just want a number. Let's plug in what we think that simplifies to. We're just going from one form to another form, okay? So let's plug in, we're saying that's the exact same thing as x plus 5 squared minus 37. Oh my gosh, they match. They match, guys. That took me 15 seconds to do that. Okay, what? Here, I'm gonna do it. I'm gonna do it on the other one. When you get up to speed, you can do these really quick. Let's do number 8. X squared minus 6x minus 5 number. Parentheses, x minus 3 squared minus 14 number. Guys, I did that in 10 seconds. 10 seconds. So please use your calculator to check. It doesn't matter what these numbers are. If you've got something plugged in differently for x, your numbers might not match mine, but it doesn't matter. As long as the two numbers match each other, you know you have gone from this form to this form correctly, okay? So please use these valuable calculator tricks and don't turn in your quizzes and tests until you go back and check the ones that you can check, okay? All right, so hope you guys enjoyed the video, and we will see you on the next one.